All right, guys, in the last video, we talked about apparatus number one, and apparatus number one was our little bitty Red Riding Hood basket going to Grandma's house with a little capsule or tablet on the inside. And this tablet is going to be caged, and it's going to get slomped down into the medium where it's going to start to break up, and it's going to start to release the active ingredient, and we're going to be able to make some measurements a little bit after the dissolution test is over. So again, the baskets are universal, and that is not a trick question. The baskets are universal. They are made to be a certain way, and that is based on USPNF criteria, because it's telling us all of the dimensions that have to be in place for this to be an approved basket to be used in the pharmaceutical arena. But the way that the paddle is inserted into the machine, that can be somewhat of a unique design. So that piece might not allow the basket to fit from one instrumentation manufacturer to the next, but the basket itself is a universal design that is deemed and regulated by USPNF here. All right. So next up is the paddle. And what I want to say about the paddles is it's the exact same as apparatus number one, except apparatus number two is just simply a paddle. That is it. So it's not a basket anymore. It's now almost like a propeller that gets lowered down into the solution. There is no shark cage for the capsule to be placed in or the tablet to be placed in. We just simply dunk the tablet or capsule down into the dissolution system and allow it to sink to the bottom. I mean, that's what apparatus number two is. So not a big major shift in the idea of dissolution here. It's just the attachment that gets added inside of the machine in order for us to complete the test. What I do want to say though is alert, 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 alert. You knew that was going to come, right? The dosage unit is allowed to sink to the bottom of the vessel before rotation of the blade is started. That is very important. So what that means is that I should not be turning the paddles or the baskets, but in this case the paddles, I should not be turning them already in the dissolution system and then drop the tablet or capsule after the fact. There is a chance that as that tablet goes down into the dissolution vessel, that paddle is going to scotch-a-pam the tablet on the side, and it's going to help break it up. And that's the whole purpose of dissolution, to see if the tablet's going to break up. So I don't want to run the risk of the paddle hitting the tablet as I drop it. So the tablet should already be dropped. The tablet should sink to the bottom, and then I should turn on the paddles at that moment. So allow it to sink all the way to the bottom. If it does not sink, there is a way that we can fix this problem in the paddle design, and that is to use what we call a sinker device. So there's a few forms of sinker devices that are out there, but guess what? The USPNF is going to control some of this and the way that it looks. So this is the design of the paddle. And just like with the basket, the USPNF is going to say, oh, when you use a paddle, they're going to have to be made a certain way because we want our results to be consistent. So this is the width of the paddle at the bottom. This is going to be the width of the paddle at the top. This is going to be the length of the stem. This is going to be the height of the paddle, as you see over here to the side. So all of these are going to be things that have to be matching before that paddle is USPNF approved, and auditors will take a look at this. They will want to inspect some of the instrumentation that you are using for the test that you are doing. And you just don't really go in and pick out a Ramarim paddle that is going to look different or be shaped different if you are performing a USPNF test. So by definition, these paddles are going to be uniform. They're going to be universal. Again, though, like the basket, whatever happens up here at the very top, however it connects up inside of the instrument, that could be a little different. But the majority of the paddle is going to be a universal design that has to be approved, that has to be made in a certain way, and that is because there are regulations in place that enforce that process to happen. So this is the paddle. Again, very easy to distinguish between basket and paddle, and these paddles are mainly going to be made of stainless steel or another inert material. It does say that in the monograph, so there are sometimes paddles that look like it has like a white plastic coating on the outside. That's almost like PTFE. Those are like our stopcock materials and our burettes and those types of things. But stainless steel is really what you see most of. As far as sinkers go, guess what? USP NF actually tells us dimensions of sinkers as well. So everything from the length of the sinker to the width of the sinker to how the grids are going to be manufactured or made in the sinker, all of these are going to be regulated, and once more, they are very universal in design. So these are sinkers that are used for paddle attachments. These are basically given to floaters. That's why we use these. We don't want the dosage to just float around up on top as the paddle is spinning. That doesn't make any sense at all, right? So we want to make sure that the dosage form, whatever that might be, sinks to the bottom. And sometimes the density of that dosage form is going to be much lighter than the density of the medium. So they float instead of sink. So what happens here is that on the inside of the sinker, I'm going to put the capsule or that tablet, and I'm going to snap the lid on this thing and drop that inside of the dissolution vessel. That weights it down, that keeps it at the bottom of the dissolution vessel, and that also allows the paddle attachment to still be used. Also keep in mind that the height of these things are going to be very important. So the height of these should not interfere with the height of what the paddle or the basket should be. And that should be 25 millimeters above the bottom of the dissolution vessel. So these sinkers have to be shorter than that, because if not, it's going to impact the paddle or the basket, and it's just not going to or the paddle here mainly, not the basket. You don't need them for the baskets. The solid dose form is going to be inside the basket. I don't know why I keep saying basket, but it's only for paddles. Sinkers are only for the paddle designs. So that way it prevents the sinker from impacting the paddle as it turns in the dissolution system. Operation of apparatus 1 and apparatus 2, the paddle and the basket, pretty much the same for immediate release. The gelatin capsules, they're a little different, right? That layer can cause us a problem. That layer somewhat has to be eaten away before the proper dissolution process can get started sometimes. If we've got to go through that motion, we got to go through that motion. Hopefully, though, regular dissolution on those gelatins will actually work and our things will pass. If not, though, you don't give up. You just hit the reset button and you add the enzymes in. For this particular immediate release, this is a regular type of tablet. So a regular tablet doesn't have any extra coatings on it, not extended delay or anything like that. A time release capsule, nothing like that at all. It is simply a pressed tablet that you will take that should just automatically break up and begin to immediately release the API or active pharmaceutical ingredient. Let's talk about a little settings and parameters with method 1 and method 2. So for method 1 and method 2, the volumes of these should be plus or minus 1%. So if it is 900 milliliters, we want 1% of 900. That is the wiggle room that we have when it concerns the total volume of the media. That 900 mils is okay to be measured out in a graduated cylinder. We do not have to pipette 900 milliliters of medium inside of the dissolution vessels. Thank goodness. Could you imagine what that volumetric pat would look like? But 900 mils in a graduated cylinder is typically okay for this process to kind of take place. Next up, the medium. We talked about the water bath, the aquarium that all of these are going to sink down into. That needs to be 37. Well, the medium needs to be 37 as well. And we already said plus or minus 0.5. Remember, I was doing alert, 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 alert. Well, all of these are alerts because all of these are going to be test questions. You know the good and well as I do. They're going to be test questions. Aliquot is this definition of a sample pull. The aliquot needs to be performed midway. So again, I'm looking at the top surface here, and I'm looking at the surface of the paddle, and I want kind of in this realm. So this cannula is what that's called. That cannula is actually a little bit lower than probably what's necessary. I want to go up a little bit more, and I want to hit it somewhere in the middle of that area. So not at the bottom of the vessel, not at the top of the vessel. I also want to keep it away from the sides of the vessel. I don't want to go to the sides and suck up from there. I want somewhere closer to the middle of that vessel container. So midway is the way to go in all directions, up and down and left and right as close as possible. We're also going to filter this with 0.45 micrometer membrane filters, so 0.45 micrometers. These are typically the membrane filters that we use in our laboratory. They almost look like plastic. They fit on the syringes, so sometimes we call these syringe filters. And the material is either nylon or PES. Not every single time, but nylon or PES does a pretty good job filtering most things that we use in a dissolution system. There are times that multiple samples could be required. So multiple aliquots are going to be required. So what that means is that if we're doing a kinetic assay, I'm going to take a sample pull, and that will be pull 1. I let it continue to spin. I take another aliquot, that will be pull 2. I continue to let it spin, take another aliquot, that will be pull 3. And this could happen at like 15 minutes in, 30 minutes in, 45 minutes in, 1 hour in, I take another aliquot. I mean, those are things that can happen inside of a dissolution kinetic assay. So if multiple sample pulls are required, that is okay by USPNF 711. But they do give you an option. They can say, well, you know, you can replace the volume with each pull to keep your volume consistent. So if you take out 1 milliliter, you're going to add 1 milliliter of fresh medium back inside of the dissolution vessel. So you're replenishing what you're taking out. If you are removing 5 mils in total, then put 5 mils of medium back in immediately after you take that sample pull. So that is a thing that is allowed. You can do that if you want your volumes to stay consistent. Or number 2, you can actually correct for the change of volumes as you go throughout that multiple pull dissolution. So meaning, okay, we start off with 900 mils. That is great. So after 1 sample pull, let's say that I pulled 5 mils out, then I now have 895 milliliters. So that next concentration that we are after has to be based on 895 mils, not 900, because I've taken 5 of them out already. And then if we do a third sample pull and another 5 mils gets removed, now we're at 890 milliliters. So this is another issue that we've got to kind of deal with, because we are correcting for the change of volumes throughout the course of time of the dissolution system pulls as we begin to do them. So this is going to impact our calculations. It's going to impact the way that our spreadsheet is going to be set up, but that's for another day at another time, not for this 115 class. All right. Finally, the other thing that apparatus 1 and 2 really pay attention to is the idea that we want our vessels covered. So there is a lid that should go on to the vessel. You see that up here at the very top. And this covered lid helps prevent evaporation. We don't want evaporation to take place over a course of an extended period of time. That it's just like boiling water or anything else, that liquid level can change, and that will affect our concentrations as we begin to calculate them. So we don't want to take that risk. And for that reason, we have evaporative lids or evaporative caps that we place onto the top of these dissolution vessels in order to prevent that change of volume from taking place. It also helps keep our vessels clean throughout the dissolution system, and it prevents anything from accidentally getting on the inside, because those lids not only keep things on the inside, but keep things from the outside getting in as well. So 2 reasons why you should use a cap on a dissolution vessel. All right. So this is the operation of apparatus 1 or apparatus 2. This says immediate release though, but it also really is in place for the gelatin coated capsules or tablets, as well as other forms of dosage, solid dosage that we see in a laboratory environment. So all of these rules are pretty much staying in place no matter what type of solid dose form that we are using. Next up, we want to talk about the medium. The medium is just really the liquid that goes on the inside of our dissolution vessel. So here's our dissolution vessel. We poured 900 mils maybe on the inside. Well, not every single time. So as far as the medium goes, well, we're going to measure out that volume. If that volume is 900 mils, you measure out 900 mils. But you're going to measure that out at room temperature. You should not preheat the medium up and then measure the heated medium out in a graduated cylinder and pour that into the dissolution vessel. Temperatures can have an effect on volumes, and you don't want to run that risk. So all of these volumes need to be measured at room temperature between 20 to 25 degrees. You cannot shortcut this system by preheating the medium and then measuring it out and then pouring it into the dissolution vessel. So based on USPNF criteria, measure it out at room temp. Have it waiting near the dissolution vessels so that way you can start pouring them into the vessels as you need them. As far as buffers go, if it does need buffered, and some do not, but if it does need a buffer and there's a pH level that's stated with the medium, then that pH number, when you check it with a pH meter, needs to be within plus or minus 0.05. That's a very tight window, folks. So therefore, if I make a buffer of 7.40, I get a window of 7.35 to 7.45. That is it. Plus 0.05 and minus 0.05. So if that's the example of what you're doing and what you're using, you don't get a lot of wiggle room for this pH to check out. So by definition, alert, 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 it should be within plus or minus 0.05 of a pH reading. Other criteria about RPMs and about time we've already talked about, and now this one gets added on as well. Good news about buffers though, buffers, the recipes will probably be given. They'll tell you exactly how much to measure out, how to dissolve it, how many milliliters of it to use. All of those are typically in a table format. There's no thought process behind it at all. You don't have to sit down with the Henderson-Hasselbalch equation. You don't have to sit down trying to calculate how to make a buffer from scratch, because they know that that is a problem that some people just don't know how to do, and they don't want to run the risk of you messing that up. So they will specifically state how to make these buffer solutions whenever they are needed and whenever they need to use. Okay. Finally, another setting parameter for apparatus 1 and apparatus 2 is the time window. They give you a 2% time interval based in terms of minutes or whatever units that you're working with. So for instance, if we had a 60-minute dissolution time period, then 2% of 60 would be applied. So if you want to kind of bring that up into a calculator, you can. I'll do it here to the side. So 60 times 2%. So 2% on a fancy calculator like this one is going to be multiplied by 0.02. That is 2%. So 2%, so 2 divided by 100 is 0.02. So this gives me a time interval of 1.2 minutes. So plus or minus 1.2 minutes here is what we would have window opportunity-wise to go to the dissolution, suck the sample out of the dissolution vat, and send it through a filter. And what I want to make clear is that it's got to go through a filter before the time stops. If you pull it, that does not mean that dissolution has stopped, because there could be some particles of a solid dose that you have pulled out of that vat that is still breaking up and still going in solution. So you want to quickly filter those with the membrane filters as quickly as possible and put those into a test tube with probably a cap on them. Only until you filter does the time properly stop here. So if it was 60 minutes in total, I'm getting a 1.2 minute interval here where I can go above or below that time frame. It's also recommended, at least for me, to go to the dissolution system and oh my god, I've got a motorized desk that almost collapsed on my lap. Could you imagine? Oh, could you imagine the squall out and the yells that I would have done? All right, so the general rule of thumb is go to the dissolution a little bit early. If you know that you're not going to work fast, if you know that you can't filter within 1.2 minutes, then go and pull the dissolution a little earlier, because you're allowed to do that, right? I mean, a time window here, and then send it through the membrane filter, and that will give you a little bit more cushion as far as the time is concerned. So with that said, that is apparatus 1 and apparatus 2 settings, no matter really what kind of dosage form that we are using. So the gelatin capsules are all applied to these settings. The typical run-of-the-mill tablet, that's kind of the instantaneous or the instant tablet, those apply to these settings. As far as extended release, everything's the same as well. If there is an extended release capsule or tablet that you have purchased that you're taking or that you want to test, then we've got to modify this a little bit. Everything is the same except for time. Extended release means that it is made to withstand a little bit longer time intervals before all of that active ingredient gets released. Normally with these extended releases, 3 pulls are going to be needed, and very often they are expressed in terms of hours. So 1 hour in, 2 hours in, 3 hours in. So extended releases are extended dissolution times, and that's just the way that those medications or maybe sometimes dietary supplements are going to be made. And because of that, we have to test them that way as well. So everybody dreads doing extended release because these do require longer time periods in order to finish. We do not really do a lot of extended release tablets, and the reason is because, once again, we've got a limited amount of time for lab, and we would not be able to accomplish an extended release in the amount of time that we are in the laboratory for. So because of that, we stay away from them, but they are out there. They are very common, and these are things that people have to test in real life. Here's an example of a medication, AstraZeneca Seroquel, typically given to kind of help people sleep at lower doses, and the higher doses are typically prescribed as an antipsychotic. So a lot of times bipolar or schizophrenia is going to be given Seroquel to help with their delusions or hallucinations that they might have. This actually on the label says extended release. So this means that this tablet, this 200 milligrams, is not going to immediately be released all at one time. It will take a course of hours before that 200 milligrams will be completely freed up. This helps shorten the amount of times that you have to take medication throughout the day. So extended release, normally taken once in the morning, and that extended release will last all the way through the afternoon and up into the evening hours. And then you take another dose in the evening hours, and that will last all the way through bedtime and until the next morning. Otherwise, if you had regular tablets, you could have been taking some at 8 o'clock and some at 12 o'clock and some at 6 o'clock and some at 9 o'clock again. It just really depends on how that tablet is going to be manufactured. So here on the thing, it says extended release. This, under dissolution, would probably take hours of testing in order to complete that process from beginning to end. Instant versus extended medications here. The red line is the instant release. So you're seeing that that line skyrockets up very quickly, and then it kind of bottoms out. Doesn't really change after a certain point in time. And extended release just does what it says it does. It takes an extended amount of time before it reaches its maximum, and before the plateau begins to happen. Great for, again, those medications that want a delayed response, a slow release type of medication that begins to go on here. And that is the purpose of extended release. Delayed release is going to be another tablet that we might see out there in the world. The delayed release has a protective coating on it that needs to be dissolved first. There's two different methods that have to happen here. I want you to think of enteric. So this protective coating is going to be eaten away, and then maybe later on throughout the process, your intestinal tract begins to absorb the medication, and it doesn't really kind of take part in your stomach as far as the breakup goes. Two different methods for these delayed releases. First is 750 milliliters of hydrochloric acid in the dissolution vessel for 2 hours. That is method A. And I want you to think of why. Because hydrochloric acid is actually the acid that is going to be found in your stomach. So the HCl here is doing the job role that your stomach would be doing, and it's helping to dissolve that protective coating on the outside. So after that 2-hour time period, we're going to pull an aliquot, and we do test that aliquot, right? We do test it just to kind of see what's there. But within 5 minutes, so you got to work fast, we are going to add a buffer to the vessel. We're going to add 250 mils in total. So that's going to give us, we hope, close to 1,000 mils, but not quite, because you did pull an aliquot, and you know the volume of that aliquot that you pulled. Was it 1 mil, was it 5 mils, or was it 10 mils, right? So whatever you pull from, well, you got to correct for that in the total volume here. So it's not quite 1,000, but it's pretty darn close. And then we've got to adjust the pH, making sure the pH looks proper. And then we undergo the dissolution for another 45 minutes. So that is the delayed response dissolution test, and that is how those are different. So put them in hydrochloric acid, allow the coating to eat away first, take out a portion and test it, but then add buffer and pH that buffer, and then allow it to go for 45 more minutes, and then take another sample pull and then analyze that one as well. Method B is almost identical. You're still going to put it in hydrochloric acid, but a full liter. It's still going to wait for 2 hours, but here you're going to drain the vessel's acid. All of the acid goes away. And then you replenish that with the same amount of buffer. A liter of buffer is going to go in. Once more, you adjust the pH. Once more, it's going to happen within 5 minutes. And then you stir that and dissolute it for another 45 minutes, just like in method A. So slight differences between these two methods, but these are delayed releases, and they are meant to dissolve much later on in your body's system. So therefore, these are meant to dissolve much later on in the dissolution system. And that's why we've got to eat away that coating with hydrochloric acid first. The enzymes are not needed here because the enzymes are not needed to eat away these coatings. Gelatin was the problem. That's why enzymes were used for the gelatin. But these are not gelatin coated, but they are coated in some type of special encasement that is going to take some time in order to break down. And that's very often slowly reactive with the acid that's going to be found in our stomach. Finally, we're going to talk about pooled samples. And pooled samples, basically, I told you, these pooled samples do not refer to one, okay? So the way that these dissolution systems are made, there's typically 4 vessels in the front, and there's going to be 2 more in the back, and these 2 in the center are normally open. There's no vessels there. It could hold them, but typically no vessels are there because they're not needed. The reason they're not needed is because the USP will typically tell us to do 6 of these solid dose forms at one time. So if I'm given a medication, I'm actually going to be given 6 tablets or 6 capsules. And 1 of those go into each vessel. And I'll do all 6 at once. And I do the pulls all at one time. So I'm going to have to kind of keep order to the chaos. And the way that I drop them is the way that I want to pull them. Go in order, keep it consistent. Well, a pooled sample, sometimes this is a thing. So what this means is that a pooled sample is an aliquot from that one, an aliquot from this one, an aliquot from that one, an aliquot from this one, an aliquot from that one, and an aliquot from this one. It's an aliquot from all 6. And they all go into the same container. That is a pooled system. It's like pooling money from a group of people. You take a little bit of money from everybody and you put it into the same pot. The same thing's happening with pooled dissolution test. You are taking a little bit of pull from all of the sample vessels and you're putting them into the same pot. You got to be careful though. It's got to be the same number of milliliters from all of these vessels. You can't have more of one than the other. So maybe 1 milliliter pulled from all 6, 5 milliliters pulled from all 6, 10 milliliters pulled from all 6. Whatever the case is, it's going to kind of tell you that in the monograph, and if it doesn't, then you make that judgment call. So one of the very first things that I showed you was a monograph that did specifically say pooled. And I told you that does not mean one vessel. And this was the monograph that I showed you in the very beginning. And the sample solution says, if method 1 is used, pipette 10 milliliters of the filtered pool solution under test to a 50 ml volumetric flask and dilute with 2% nitric to 50 mils. If method 2 is used, dilute the filtered pooled solution under the test with 0.125 normal hydrochloric. So they're giving me options on what to do here, but that is what they are referring to as far as a pooled solution goes. So this is a representative sample. You're pulling a volume out of every single dissolution vessel that is out there. And with every one of those vessels, they go into the same container. And then you're going to have a total of a certain amount of volume that's been pulled from each one of those. Based on how the monograph is written, well, those pooled solutions, there's going to be maybe some extra prep work. So it says, if method 1 is used, pipette 10 mils of the filtered pooled solution. Well, 1 mil per vat is not going to cut it here, right? If I do 1 mil per vat, I'm going to end up getting 6 milliliters in total, but this is going to require 10 mils at least. So that means that with this pooled solution prep, maybe I need to pull 2 mils from each vessel. If I do 2 from the 6, I'm going to get a total of 12 milliliters. So I filter that 12, and then I need 10 of that to go through the sample prep here. The same thing with method number 2. Filtered the dilute pooled solution under blah, 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 blah. So again, I've got to kind of know what I'm doing in order to figure out how much to pull from. As long as I'm pulling the same amount from all 6, that's really all that matters in the initial stages of the dissolution system. All right. So finally, what I want to say here is pass and fail, right? What contributes to a passing score and a failing score with the dissolution system? Well, like I said before, most of the time we start off with 6 tablets. And with those 6 tablets, what we are looking for is this idea that these tablets should pass. These tablets should show us performances that are very good. And the definition of a good performance is not less than 5% that's stated on the label. So if it is a 100 milligram tablet, I should see 100 milligrams getting freed up. If 100 milligrams is not there, and as long as I get maybe 95 or higher, that is not less than Q plus 5%. Q is the stated label amount. That's what the variable represents. All right. So 5% of 100 is 5. And I can go down to 95 milligrams. If all 6 of those are 95, 96, 97, 98, 99, and 100s, then we're good. the tablet will pass the dissolution test, and we don't got to worry about it anymore. All right. And this is going to stay true to gelatins, or to instant release, or to extended release, or to these delayed release medications. I mean, this is kind of the common run-of-the-mill thing. Start off with 6. If those 6 pass within a 5% window, then you're great. You don't need to do anything else anymore. Stage number 2, though, is if they do not. If one of those, just one, falls under that 5% window, then we've got to do 6 more tests. We've got to do 6 more capsules or tablets. So this is going to give us a total of 12 now, 12 data points. So we're going to average those 12. Whatever number of milligrams that you get from each one of those, you're going to average all those up. And that will provide you an average Q value. So the average of the 12 is greater than Q, and no unit is less than minus 15%. That's what we're looking for here. If any one of those is less than 15%, it's not going to work out for you, folks. You go on to stage 3. Oh my God. Stage 3. Next up, stage 3 says, okay, if you made it this far, your first round of 6 have failed. Then you did another round of 6, giving you a total of 12. You determined that that failed. So now with stage 3, we're going to do 12 more. And that's going to give you a total of 24. Those 24 are then going to be averaged as far as milligrams go. If no more than 2 are less than 15% less, then you're good. And if none of them are less than 25%, then you're good as well for that one as well. So there are chances that we go through 3 stages of dissolution testing, and there are chances that we will end up using 24 tablets or capsules throughout this process if we were doing this for real in real life. We never go through this motion in our laboratory environment because this would take forever. We get you to do 1, and we kind of average everybody else's in the class around. At least we get a total group of 6 at least. And then we can make a judgment call on what happens from there. But this is a typical table that you would see here as far as what is accepted and what is not accepted. Up here at the top, notice it says 7-11 for immediate release. Very similar, though, for the other dosage forms. We start off with 6. Each unit is not less than Q plus 5%. Next up, if that fails, we do another 6, round 2. That gives us a total of 12. The average is equal to or greater than the Q. And B, no unit is less than Q minus 15%. And then if that fails, we do another 12 for a total of 24 now. And we got to meet all 3 criteria. The average of all 3 is equal to or greater than Q. No more than 2 of those are going to be less than 15%. And no unit is less than 25%. So within the USPNF 711, here's the document. Here it talks about the gelatins that we talked about already. Gives us some information about baskets, which are apparatus number 1. Some dimensions. None of those you need to memorize. Here's apparatus number 2 and dimensions, none of which you need to memorize. Here are the sinkers for the paddles, which you do not need to memorize dimensions for. Talks about apparatus 3 and apparatus 4, which we are not going to discuss. As I keep flipping pages, I'm then going to get to a section here that says procedures. This is where it gives us all of those setting parameters, what's acceptable temperature-wise, time-wise, so forth. How to handle the different dosage forms, everything from immediate release to extended release to delayed release. If they are delayed release, okay, well, we got to hit it with some acid in the beginning, and then we hit it some buffer as a follow-up. Again, apparatus 3 and 4, we're not going to discuss. And then here's the interpretation of the results. So this is where that table is coming from that we just talked about. Unless otherwise specified in the individual monograph, the requirements are met if the quantities of active ingredient dissolved from the dosage units tested conform to acceptance table 1. Continue to test through the 3 stages unless the results conform at either S1 or S2. So start off with S1 first with only 6. If that fails, go to S2 and do another 6. If that fails, then go to number 3 and do another 12. The quantity Q is the amount of dissolved active ingredient specified in the individual monograph, expressed as a percentage of the labeled content of the dosage unit. So that Q can be very confusing. What is that number? Because it looks like Q is going to help me determine if things pass and if I've got to do 6 tablets or if I have to do 24. So the Qs are referring to in the dissolution test within the monograph. So here's a monograph for sodium naproxen tablets, aka Aleve. And if I go through and I look under the performance test, I'm going to see dissolution. That's right up here, front and center. That dissolution test toward the very bottom has a tolerance. This is my Q value. So the tolerance is not less than 80%. That is what that is telling me. All right, so if I do the dissolution round 1 and I do 6 tablets in the dissolution system, if those 6 tablets, okay, I'm going to calculate the milligrams, and I'm going to calculate the milligrams, and those milligrams, maybe the tablet needs to be 200 milligrams in total. I don't know, right? So let's say that we are calculating 180 milligrams instead. And that tablet needs to have 200 milligrams that are present. What happens is that I calculate a percentage here. So I'm going to take the lab data, 180 milligrams that was released, and I divide that by what those tablets should have had in them per dose unit, and then I multiply it by 100%. So this one particular tablet has a 90% value. 90% of the stated label is actually there. All right, well, does that pass? Okay, not less than 80. So yes, that one tablet passes. Absolutely, it does. It passes. So I'm going to have to do this for all 6. So let's say that 90% is done, and I get another one at 85%. I get another one at 80%. I get one at 97%. I get one at 88%. And I get another one at 82%. Okay, here are my 6 tablets. So I've calculated the actual number of milligrams from each one. I've divided it by the stated label amount to get a percentage. And these were the percentages that I've got from those 6. So based on the dissolution test, it says no less than 80%, and then it passes. Okay, so 90 is not less than 80. Check, 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 check. That 80% came real close, but it still passes that tolerance, doesn't it? Okay, well, you're going to finish the dissolution test. You're going to turn in the data. I'm going to get the data in a real lab, and I'm going to go, oh, no, this does not pass as a batch. And you're probably thinking, what? Why doesn't it pass as an entire batch if each individual one did? Because the monograph piece tells you to do something a little different. The monograph piece is actually going to come in and say, well, you only have to do 6 if your unit is not less than Q plus 5%. So what this actually means is that if I go back to this monograph, my Q is 80 plus 5%. That is going to be 85%. So the only way that you can clear out the initial 6 and not do any more dissolution tests on them at all is if each one of these individual tablets are going to be greater than 85, because that is what that tolerance table tells us. So that tablet would pass that new threshold. This one would pass. This one would pass. Uh-oh, Spaghetti-O. Uh-oh, Spaghetti-O. These two do not pass the Q plus 5. So therefore, by default, what's going to happen is that we need to go and do an additional 6. Just simply because, I know, it sounds crazy, but just simply because those first 6 did not pass good enough. We need more stats to back it up. That's what this is all about. So we're going to do another 6 tablets. We're going to average those S1s and those S2s. And then we're going to see if that is greater than or equal to, in this case, 80. So at the end of the 12, I'm going to take my individual percentages and I average those individual percentages up. Those individual percentages, 80 plus 82 plus 86 plus 90 plus 92, whatever number that is, if that average is equal to or greater than the Q value, which was in the monograph, then we can clear it out. Yeah, we've got 12 tablets, we got more stats, we can do more calculations, we feel better about this data set, so therefore we get it a final clearance at that moment. However, if any unit is less than Q minus 15%, 80 minus 15, 80 minus 15, that's 65% in this example. If any of them fall below that, then by default we go to the third stage, and that third stage is going to be another 12. And now we average all of those together and we look for additional criteria. That is the Q that this table is talking about. That's how we handle this data in the long run. And that Q is going to come from the tolerance that's going to be stated within the monograph. All right, so I think that is all I need to say about dissolution. So you got 3 videos now, a little bit more than 2 hours of total lecture on the laboratory portion. So have fun with 7-Eleven dissolution. Again, it's more about the thought process and the theory. I'm staying away from a lot of the calculations, so to speak, with the dissolutions. Just really definitions on what those are going to be. But that's what dissolution is all about. So very often in real life situations, I am doing more than 6 tablets, but I'm at least doing 6 in a batch run. So I'm doing 6 for the first batch. And if that fails and I got to do the second batch, I do another 6. Hopefully that will pass. Hopefully we won't have any more issues. But if we do a third round, and that's going to require 2 more batches of 6 if I'm unlucky. So good luck on the online assignments. I hope and I think that you know more about dissolution now than what you did in the beginning. And then until next time, I'll see you again, and I'll drive you crazy with more details. Bye-bye.